Okay, 4.0 getting ready. The first thing that we need to do in order to prepare for Unit 4 is to go over some things that we learned in previous years. The first one of those is scatter plots. So a scatter plot is just a way of displaying data, information using a graph. So here we have an example. You have the data in front of you. You have the drop height of a ball measured in meters and the bounce height of a ball measured in meters. So in that first column, you can see when it's dropped from 1 meter, it bounces up 0.3 meters, which is 30 centimeters. So this experiment measured how high a ball bounced after being dropped from 6 different heights. What is the independent variable in this case? The independent variable. Okay, so we have 2 variables, right? The first variable is drop height. It changes. It goes from 1 to 1.5 to 2 to 2.5, 3, and then 3.5. We also have the bounce height. Now if you think about the situation, the height that the ball is going to bounce depends on how high you drop it from, right? So the bounce height is the dependent variable, whereas the drop height is the independent variable. Okay? So in this situation we have drop height, which is independent, and we have bounce height, which is dependent. And whenever we're drawing a graph, which you have before you on your worksheet, we always use the x-axis as our independent variable. So our x-axis is going to be labeled drop height, and we also want to identify that it's being measured in meters. Our bounce height is our dependent variable. And we also want to identify that that is measured in meters. Now, what kind of scale do you think that we should use for our independent variable, our drop height variable? What kind of scale, what numbers should we use along the bottom? How high do we need to go?
4.
Yeah, we'll go to about 4, right? Because the highest drop height is 3.5. So if we make this last one 4.0, and then we split it about in half, we get 2.0. Split each of those in half, we get 3.0 and 1.0. And that's a quick, easy way to help us do a sketch of our graph. What about our scale for bounce height, our dependent variable? How high do we need to go on that scale?
1.5.
Sure, 1.2, 1.5, somewhere in that region. Okay, so I'm going to do my highest point as 1.2, split it in half-ish, it'll be 0.6, split that in half, I'd have 0.3 and 0.9, and that's probably enough for me to draw an accurate graph here to plot my points. So the scatter plot, once we plug in our information, is going to show the relationship between the 2 variables, and we're going to be able to analyze that relationship. So let's go ahead and use the data that we're given and plug in those points. Our first point is the point 1 and 0.3. So drop height 1, go up to bounce height of 0.3, draw a dot. You may continue on to do the rest on your own and check back here to see how you did. So after plotting those points, we can see that there is a relationship between drop height and bounce height. As we drop the ball from a higher measurement, a higher height, the ball will bounce higher. But we also notice that this relationship is not perfectly linear. So it's different from the types of relationships that we've been studying so far. If the trend in the scatter plot continues, if this trend, this general trend continues, that as drop height increases, bounce height increases, what height do you think it will bounce to at a drop height of 4 meters, or let's say even 5 meters?
1.4.
Anyone else want to take a stab?
4 meters, 1.3.
Yeah, just somewhere out here, right? Somewhere out here at 1.4, 1.3. It's just an estimation if that trend continues. Okay, the next thing we need to brush up on is some vocabulary and skills involving translations and reflections. So translations and reflections are both types of transformations. So these are types of transformations. Find a place to write that on your sheet. And this word transformations, we're going to be talking about quite a bit this unit. It just means any way that you are moving or changing a basic graph. Okay, so here we have two figures, and they are being transformed. One of the transformations is going to be a translation, and the other one is a reflection. Your first image shows a picture of a translation. We're going to perform a translation on that image. And I'm drawing just a quick sketch of what your figure looks like. It's okay if it's not perfect. And all we're going to do is translate it. In order to show a translation, we're going to draw a translation arrow. But first we're going to move that figure. So go ahead and pick somewhere else on the chart, move it a little bit to the right and maybe one block down, so that you have the exact same figure. It hasn't changed shape or size or anything. It has just been moved. It's just been moved. And now if we take 1 point on our original figure and we identify the corresponding point on our moved figure, our second figure, okay, if we identify 1 point on figure number 1 and the corresponding point on figure number 2, and we use a ruler to draw an arrow from the point on figure 1 to the point on figure 2, we have now mapped that translation using a translation arrow. Translation arrow, right there. In your second box there, we are going to perform what's called a reflection. A reflection. So again, I'll try to draw the basic shape that you have. It's just a quick sketch. And what we want to do is reflect it. Well, if you look in a mirror, or if you think about the word reflection, it really just means to flip it, right? It just means to flip. So draw any sort of line, maybe 1 or 2 blocks away from the figure. And then you're going to reflect that image. So if this point is 1, 2 dots away from the line of symmetry, the reflection line, then my next corresponding point also has to be there. Let's say this dot is 1, 2, 3 away, then this one has to be 1, 2, 3 away. And go ahead and draw your new shape as best you can using the dots that are provided for you on your grid. Whenever we have a figure that's flipped or reflected over a line, that line is called the line of, you guessed it,
Symmetry.
Symmetry as well. It's definitely a line of symmetry, but we call it the line of reflection. So the line of symmetry is also the line of reflection. It's the line that the figure was reflected over. And that's going to start happening with graphs when we flip them over the y-axis. So that will make more sense as you start seeing some of the graphs that we do. Good. In your homework, you'll notice that there's a small section on translations and reflections, which you can do at your own leisure. Our next topic of review is operations with powers. We have to have a pretty good mathematical command of dealing with numbers that are expressed as powers, okay? So I'm going to write a little sentence that describes what a power is, and then we're going to show a little example. A power is a product of identical factors and consists of a base and an exponent. A power is a product of identical factors. It consists of a base and an exponent. I'm going to pick a couple key things out of there. A power is a product of identical factors. It's big words. It's not that hard to understand. When we hear the word product, what operation are we dealing with?
Multiplication.
Multiplication. So if we have the power, let's say a to the power of 4. All that means is this is the power, and it's a product of identical factors. So that means it's a times a times a times a. It's identical factors. Every factor is a, and it's the product of those factors, which means we're multiplying the factors together. A to the power of 4 just means a times a 4 times. Okay? Now, we've noticed also that there are two parts to a power. There is the base and the exponent. Okay? The base and the exponent. In this example, 2 to the power of 4, 2 is the base, and 4 is the exponent. Together, they are called a power. So 2 to the power of 4 is a power. It has a base of 2, an exponent of 4. You have also learned, and now we're going to review, some rules for working with exponents and powers. Okay, there's exponent laws, and they can be used to simplify expressions. Remember, expression is just a mathematical sentence involving powers with the same base. So we're going to take a second now to review those. Okay, I have copied down the same chart that you have in your book. I've given the titles there: operation, exponent, and example. What are some of the basic operations that we deal with in mathematics and algebra? Multiplication, division, addition, subtraction. Okay, those are the basic operations. When we're talking about exponents and powers, we're talking about identical factors. So we're not actually going to worry about addition and subtraction so much. What comes into play with powers is multiplication, division, and powers. You can have a power of a power. And we'll see what that looks like in a second. So the first operation that we're dealing with is multiplication. And when we're doing generalizations and examples, we're going to use just variables. So A's, B's, X's. We're not going to put in exact numbers until we get over here to the example column. Okay? So if we're talking about multiplication with powers, then we might be talking about something like x to the power of a times x to the power of b. And when we use our exponent rules, this really just means that we have x a times and we have x b times. So we have a bunch of x's here multiplied together, and then we're multiplying them by a bunch of x's here. So really all we're doing is saying we have a x's and we have b x's, and so when we multiply them all together, we just have x to the power of a plus b. This is the multiplication law of powers, or the multiplication law of exponents. Let's see an example of this. So let's say instead of just using variables, we use real numbers. Let's make our base 3 and our power 2. And we're going to multiply 3 to the power of 2 times 3 to the power of 3. Well, if we expand this, we have 3 to the power of 2. That means 3 times 3. Right? And then we're multiplying it by 3 to the power of 3. 3 to the power of 3 means 3 times 3 times 3. Well, what do we have here? We have repeated multiplication of identical factors. Our base is still 3, but how many factors of 3 do we have? 1, 2, 3, 4, 5. And isn't 5 just 2 plus 3? So all we've done is added the factors from our first term and the factors from our second term, and we've simplified it into 3 plus 5. The law there is right here. The multiplication law of exponents. Any base to a power times that same base to another power is equal to the same base to the power of those guys added up. The next operation that we're going to look at is division. Division. In general terms, just like multiplication is adding the exponent, in division we subtract the exponent. So let's say we had a situation where we have a power on the top, let's say x to the power of a, and it's being divided by x to the power of b. This is the same as saying x to the power of a minus b. That is the division law of exponents, and we'll show how it works with a specific example. Let's say we had, I'm going to pick new numbers, let's say we have 2 to the power of 5 over 2 to the power of 3. Well, what that really means in the numerator is that we have 2 multiplied by itself 5 times, right? 2 times 2 times 2 times 2 times 2. And in the denominator, we have 2 multiplied by itself 3 times. 2 times 2 times 2. Well, one of the most basic rules that we have with regard to division is that if we have the same factor in the top and in the bottom, what can we do? We can cross them out, because this 2 divided by 2 is just 1. So that's 1, that's 1. This 2 over 2, well, that just reduces to 1. This 2 over 2 reduces to 1. And what are we left with in the numerator? Yeah, we're left with 2 powers of 2. And in the denominator, we're just left with 1. So this reduced to 2 to the power of 2. And isn't that just the same as 5 minus 3 in the exponent? So there's an example for the division law of exponents. The third law is probably the most unfamiliar, but it's not super tricky either. It's called powers. And we say it's the power law of exponents, or sometimes it's called power of powers, because exponents can be called powers, so it's the power of powers law. That's usually how I'll reference it, or the POP, powers of powers. Okay? So the power law says this: if we have some base to the power of a, and then we take that expression and we raise the whole thing to the power of b, then remember, because using powers is just repeated multiplication, that's saying that we have x to the power of a b times. So we have x to the power of a times x to the power of a times x to the power of a as many times as b tells us to do it. And a tells us how many powers of x we have within each of those x to the powers of a. So I'll just show what happens here, and then we'll do a basic example. This means we have x to the power of a times b. Power of powers. X to the power of a times b. I'm going to scroll up a little bit to give me some more space for our example. But let's say we had a base of 3 raised to the power of 2. And then we wanted to raise that whole thing to the power of 3. Well, each of these 3 to the power of 2's is 3 times 3. And we're going to do that 3 times. So we have 3 to the power of 2, which is 3 times 3. And then we have that to the power of 3. So we have 3 times 3 times 3 times 3 times 3 times 3. Okay? So here we have 3 to the power of 2. And because it's raised to the power of 3, we have to have that 3 times. Well, this is just 3. How many times?
6.
3 to the power of 6. And isn't the exponent of 6 just 2 times 3? Okay? So these are 3 rules that you're going to have to remember, and we're going to be using them fairly regularly. Okay? A couple of keys to remembering them is the multiplication law of addition of exponents is when you're dealing with multiplication between powers. Okay? So we're dealing with multiplication and we're dealing with powers. What do? We add the exponents. Okay? So it's multiplication because that's what's up here. You're doing that to the powers, but you add the exponents. With division, we have a division involving exponents with the same base, and we're going to subtract the exponents. With the power of powers rule, okay, we have a power raised to an exponent. So we have a base raised to an exponent, and then the whole thing raised to an exponent. And then we're going to be multiplying them, and we've shown why that works in our concrete example, and we'll be using them more often. Your practice for Getting Ready 4.0 is attached to the lesson worksheet, and you can try all of those problems, please.